The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices.
Our last presentation is a local case study using high-volume fly ash concretes. The presenters are Mike Ramerth, principal with Meyer, Borgman & Johnson, and Linda McCracken Hunt, also a principal with Studio 5 Architects, and the case study is the University of Minnesota Recreation Center expansion.
Good morning. My name is Linda McCracken Hunt. I'm with Studio 5 Architects in Minneapolis. And we were leading the design team on the design of the expansion of the University of Minnesota's Recreation Center. Our agenda, the introduction, the vision, the engineering, and the concrete mix designs, construction, and lessons learned. This is an image of when most of the students will see the Recreation Center, which is in the winter, which extends in Minnesota from September till May. At least this year it feels that way, but this is a rendering of the expansion of the project. The University of Minnesota has a very large campus, a lot of students, and the students actually tax themselves with a student services fee to build an expansion to the Recreation Center so they would have more fitness space. And it's a beautiful building that is just getting completed. It'll open up for the students this fall. It's about 160,000 square feet of new construction on 4 floors with a basement, a lower level, and we've about doubled the size of the rec center. And this shows an atrium within the building with a lower level climbing wall that's about 34 feet tall, free weights, a tiered fitness area with a 4-story atrium. And then up on the 3rd level, the running track comes out into the atrium, so you get to run out in the atrium space. And the running track is about 9 laps a mile. So it's all about exposed concrete structure, the architectural aesthetic of exposed concrete. This shows a rendering also in a winter condition with that yellow running track coming out through the atrium. This is a Revit model. The project was designed completely in Revit, and this is showing the fitness tiers, the running track coming out into the atrium, the lower level with the climbing wall, and then the west end of the building is actually administrative office space. The lower level, which is below grade, has mechanical locker rooms. It has a tiered spinning room where the bicycles can go biking through the Alps with surround sound and large screen imagery. A very large electrical service. The decision was made to not do an emergency generator, but to instead install 2 independent electrical services, and then a large climbing wall. This next level up is actually the 2nd floor, a large multi-purpose room. This is for yoga and different kinds of classes and students' classes, but also can be for meetings. Shows the atrium fitness platform looking down into the atrium. The running track level. A large Supermac gym with a rubber floor, resilient floor for a variety of indoor soccer, floor hockey, basketball, volleyball, badminton, a number of indoor activities. And this is a view of the lobby. It's interesting, since you're all into concrete, that we have all of this exposed concrete, and the client didn't like the exposed concrete columns, and they actually turned out beautifully, but the client wanted the ones in the lobby wrapped in wood. He couldn't connect with that aesthetic. This is also a view of the lobby. The running track coming through the atrium, the tiered fitness levels, and a ramp coming up the side. This is all wood. All a neutral gray palette, the exposed concrete, and then we have a mesh ceiling that gives the illusion of a plane of ceiling, but you can see up above to all of the mechanical, electrical, which was painted out with the gray to match the concrete. A view from the running track looking back. These are renderings, the Supermac gym and the climbing wall. So the project is working toward completion right now. It's going to open for the students in the fall. And Mike's going to explain some of the engineering challenges on the project.
Good morning. My name is Mike Ramerth, and structural engineer on the project, SCR. And I always like to start out with a little story. Are there any finishers in the room? Darn. Well, how about structural engineers? We got a couple. Good. I'm going to take you back to the French Revolution. The height of the French Revolution, and there's a priest, a concrete finisher, and a structural engineer headed toward the guillotine. Now, don't ask me what they did to deserve that. From what I've read, you didn't need much of a reason back then. And they arrive at the guillotine, and the priest must have drawn the short straw because he's up first. And the executioner asks him, do you want to be face up or face down? And the priest says, well, I'd like to be face up. I'd like to be able to gaze toward the heavens and be looking in the direction of my Maker as I meet my end. So they put the priest in the position in the guillotine, and executioner pulls the lever. The guillotine blade comes rushing down and stops just a couple of inches above the priest's neck. And the crowd gasps, and the French officials are amazed, and they say this must be divine intervention. And the priest is set free. So now it's the finisher's turn. And he says, the executioner asks him the same question, of course, face up or face down. And he says, well, if it works, don't fix it. I'm going to go face up, just like the priest. Sure enough, they pull the lever, the blade comes down, and again, miraculously, 2 inches above his neck, the blade stops. A hush falls over the crowd again, and they set the finisher free. Truly, he must be a just man as well, and you're free to go. So now it's the structural engineer's turn. They ask him the same question, face up or face down? And the engineer says, well, it worked out pretty well for the other two fellows. I'll go face up. So they get the engineer in place, and just before the executioner pulls the lever, the engineer blurts out, hang on a second, I see the problem. I hope the priest and the finisher got away quick enough after that. So anyway, to proceed here, the structural system. That's a familiar sight to many of you, no doubt. Beautiful cast-in-place deck being ready to be placed. Wide module pan and joist with both flush beams and drop beams. Predominantly, this was a mild steel reinforced structure. Another nice view of the pan and joist system. Shot from the underside. This happened to pick up a transfer beam here. And wouldn't you know it, our mechanical friends had to have ductwork through the beam. Here's a shot of that running track that Linda was talking about 8 feet wide, and I'll just point it out right now. Very few, if any, cracks in that ribbon of concrete, and that was about a 6-inch slab, but actually 3 inches over 3-inch metal deck. Very low shrinkage mix. A couple of shots from the tower crane during placements gives you another idea of the structure, the magnitude of some of the placements. The lateral system was largely concrete shear walls, but we also used these blade columns along the south elevation for lateral as well. Why high volume fly ash and high volume supplementary cementitious? I'm going to talk a little bit about slag as well here, and a little bit about limestone, as did Dr. White. Sustainable design, greatly reduced global CO2 emissions, enhanced durability, enhanced placeability, workability, significant reduction in landfill ash. Fly ash is half the cost of Portland cement. It's actually a little bit lower than that. And I'm going to mention slag here too. That's about 90% of the cost of Portland cement. My slide that I've used for several years is 5 to 7% of global CO2 emissions are attributable to the production and transportation of Portland cement. Dr. White had it a little bit higher, but that's why we need to keep using these blended mixed designs. Here's our recommended replacement levels in the real world. The higher values are, I'd say, the blends or the replacement values that I use, with the possible exception of January and February in this neck of the woods. So for structural decks, we're up to 40%. We try to get that, and we did use that on the rec center. Slab on grade, slab on metal deck, the same. We kept them up at 40% all the while. Columns and shear walls will actually get up to 50%. Some projects we did not on this one. Foundation walls, very high replacements again. Footings even higher if we can go. We did not here. I was hoping we might have, but we didn't. And then for mass concrete, which we didn't really have, we get much higher. I like to show this slide too because it's part of our specifications, and it's also a critical part of our mixed designs, and that is we recommend on most of our concretes a well-graded aggregate. This is important. This is the Shillstone 818. Now I'll tell you that I've never rejected a mixed design because it didn't meet the letter of 818. I'm a realist, and I know that that's difficult to do. As long as an honest attempt is made to get these larger aggregates in the mix, the whole point is reducing the water demand of the concrete and aggregate packing the concrete so you can lower the paste value. The strongest part of the matrix is the aggregate. Dr. White alluded to that. You know, when he said we hope we used a little more aggregate than his simplistic picture indicated, and we definitely do. We know it's extremely important. Green concrete, it's the right thing to do. I'm going to hammer that home a couple times today. Here's our mixed designs, kind of related to our specifications. See here that for a 4,000-pound footing and foundation wall, we had a little higher water cement ratio. That's no problem. You can even go a little bit higher. I want to focus on this, and that's throughout all of our specs. We take a two-pronged approach to green concrete, and that is, number one, limit the total cementitious content. We've been over-cementing our mixes for decades, and we've got great results with keeping many of our mixes down at 520 or even below that. So we limit the total cementitious, and then we replace 40%. On all of these mixes on the rec center, we had 30% fly ash replacement and 10% slag on each and every one of these that I'll show you here. Average slump with WRAs was at about 5.8. Normal air, this wasn't entrained, it was just entrapped. And you can see the compressive strengths were pretty impressive. Next one was the shear walls. We'll go through these quickly. 5,000 PSI. We're up at a 4:5 water cement ratio. Here we went up to a 560 total cementitious. Again, 40% replacement with the ash and slag. And very good performance strength-wise again. This was the flat work and the columns. 6,000 PSI. We were down to a 4:2 water cement ratio at 640 for total cementitious, and again 40% replacement. Compressive strengths were very good. And now here we're starting to show set times, because then the flat work is where it becomes relevant. Set times are a big issue when using these high replacement mixes. And I was delighted to see some of the things that Dr. White presented as for ways of accelerating these set times. Here we were at 1 hour and 25 minutes above the set time of straight Portland that had been tested. Not bad, but the finishers, we want to get them home for dinner, and that's a big deal. Time is money. There's a few more. There was a few hours of overtime on this project related to set time, but they were very few. And I've got testimonials from Ken Sterland, who was the project manager for J.E. Dunn, Dean Hansen, who was the project superintendent for J.E. Dunn, and Galen Peterson, who was the project manager for Kelleher Construction, the concrete contractor. And they all gave these mixes a good rating. They said there was a few hours of overtime, but it wasn't excessive, and it was certainly no delays. Construction schedule was held and all of that. I'll just stop here and make a general statement too. How often do you hear the best in the same sentence with the easiest or the cheapest in this world? Not very often. These mixes do take a little extra care and a little extra effort, but they are wonderful mixes, and they're green. Slab on grade, slab on metal deck, down to 4,000. Total cementitious back down to 520 at a 4:5 water cement ratio. At the end of this presentation, I'm going to tell you about the research project that we did with the Minnesota Concrete Council, which even takes these numbers down lower. And I'll conclude with that. But again, now here, we're only at a minute 15, or pardon me, hour 15 greater set time, longer set time than we had with the straight Portland. Note the shrinkage values here too, they're excellent. Construction and lessons learned. Constructability. Set time is the key. How do we get these mixes to set more equitably with straight Portland? And we're working at it all the time, and I'm definitely interested in exploring some of these approaches with internal curing and getting more ground limestone, finely ground limestone in the mix. It sounds more expensive, and we'll have to look at that carefully. I was surprised to hear that just recently that every bag of Portland cement you buy these days has 3 to 5% ground limestone in it already. That was news to me. So our mixes here, unbeknownst to me, were really quaternary blends, because they had slag, fly ash, Portland, and limestone in them, and they did quite well. Here's some of the issues that we've seen. Surface crusting, and I'm going to talk about that in a little bit. Keeping that surface alive, partly due to the lack of bleed water. Again, like I mentioned, finishers home for dinner, lack of bleed water. These mixes typically need evaporation retarders. And then, of course, the set times that are problematic are only exacerbated in the winter when it's cold. Cold temperatures exacerbate the situation. What we found is that non-chloride accelerators are helpful, up to 2%. I will allow calcium chloride accelerators in plain concrete that has a dry service life. That's even more effective. A known accelerator that we use in parking decks, pool decks, bridge decks is calcium nitride. It is a known accelerator and corrosion inhibitor, so you get a double benefit. It's not cheap, but keep that in mind for your extreme condition concrete, your corrosive environments. Here's some of the other things that are critical, especially in cold water, in cold climate, cold seasons, is keep that mixed temperature above 70 degrees. That's critical. You do that by heating the water, which is also expensive, but it is very effective. Keeping the aggregate somewhat protected in a tempered space where it doesn't get snowed on and left to the 20 below temperatures. You introduce that ice cold aggregate into that mix, and it drags that temperature down dramatically. And of course, temporary heat on site during the day of the pour, the night before, is critical. The use of the surface evaporation retarders, such as Confilm, Aquafilm, Eucabar, we found to be very effective, especially on a wide module pan and joist deck where you have the deeper elements, the beams and the joist stems, which take a little bit longer to set. You want it to set bottom to top. And so that's where the surface crusting comes in. You've got to keep that surface alive, and these retarders do a great job of that until you can get that bottom to set top. Again, now this is a little controversial, but it's worked in the field. Applied after screed and before bull floating. People say you shouldn't be working a surface retarder into the surface of the concrete. This is true, but I have not seen any significant deleterious effects from doing so, because then after the bull floating, again, depending on the conditions, let's say it's a windy day, a dry day, you have to keep that surface alive, especially in the wide module pan and joist, so you get that bottom to top set. And so we have them reapply the surface evaporation retarder to keep that surface alive until they can get on it and finish it. The other mistake that's made is the contractors will sometimes take that Confilm or Aquafilm and they'll cut it 5 or 6 times to 1, and you really eliminate its effectiveness when you do that. You know, I've worked with several of the leading contractors here locally, and they say that we'll cut it 2 to 1 tops, and then you stretch it a little further, and it's still very effective in keeping that surface alive. And then the use of wind screens also is very effective. So these are some of the practical day-to-day things that we've learned about how to get these mixes in place successfully, and they really are great mixes. This is the research that I alluded to earlier that I wanted to cover briefly. This was published in last July's Concrete International. I don't know how many of you know Dan Bruno. He co-authored this with me, and actually he did most of the work, so I want to give him credit. Dan's a great guy. And what we did is we focused on trying to optimize a slab-on-grade mix. Down here, just point out quick, this was our attempt to, at the 818 well-graded aggregate. Hard to see, I'm sure, from where you are, but that one did meet it exactly. Here's the mixes that we tested in the lab. There was 13 of them. And you can see in this column, well, the first column is the water cement ratios. Second column was the total cementitious, 520, and we had several at 480. We were pushing the limits of the total cementitious, again, in our effort to make it as green as possible. Like I said, and I firmly believe this, we've been over-cementing our mixes for decades. So, the highest total cementitious we had here was 520, and many of them were 480. You can see here the replacements. Mix 1 was 40% fly ash, mix 2, 20/20 slag and ash, and on down the line. The next column was the set times. Again, this is the critical piece of this research. And I want to point out down here that even in the lab, we had some reasonably close set times. And I'm going to point out mix 11 because this did even much better in the field. The next slide I'm going to show you is a field test of the four highest performing of these mixes. Again, I can't argue with it. The straight cement, the straight Portland cement here with no replacement was the shortest set time. I should point out, I guess briefly too, fantastic shrinkage values of all of these mixes. And then this last one is the finishability rating. 1 being the poorest, 3 being classified as moderate, 4 good, and then 5 is excellent. We didn't have any 5s. But we certainly had several. I mean, if you take a look at these, even the straight Portland didn't get a great rating. So many of these had better ratings than the straight Portland. All right, moving right along. These are the 4 highest performing mixes that we actually put out in a Target store in Inver Grove Heights here locally. We've got some contractors to work with us and had very good results with these. Number 11 ended up being our highest rated mix, 480 total cementitious, 20% fly ash, 20% slag, water cement ratio of 0.50. Now that, some of you might say that's pretty high. Well, frankly, on the basis of this research, I'm going to probably raise my specs in that 0.48 to 50. I've had them at 4.5. And I've been convinced that going to 5.0 really does help, and it helps dramatically. It seemed to help on the set time. That is very close to straight Portland cement set time by giving it a little extra water. It's akin to Dr. White's approach of internal curing, giving it more concrete, or giving it more water to hydrate and more thorough curing, and it really does seem to help that set time as well. So that was an eye-opener, and it really got my attention. And again, the finishability was moderate, very low shrinkage, and it was a beautiful mix. So with that, I will open it up to questions. Yes?
On the 480 cementatious, couple of questions. Did you use any super or mid-range? That's number 1. Number 2, is that smooth washed gravel, a local deposits, or is that a crushed stone?
It was crushed limestone. To answer your second question, what was the aggregate? First question was, remind me, was on the 480. What was your question again? Oh, yes. All of these mixes had, they were mid-range. Was there any high range in them too? They were Josh produced these mixes, Josh Edwards with ABR. And so they all had mid-range water reducing admixture in to achieve the slumps and the placeability.
And you're saying it's natural sand?
Yep.
Natural sand. Yes.
What was the gauge of the compressor strength? 28 day.
That was 28-day strengths. I should have mentioned that.
Wow.
You amazing.
40% fly ash makes it so strong. 28 days.
That ternary blend really makes a huge difference.
You know, just to make a comment.
Come on up here.
You were using the word retarder so much to keep the surface alive. I mean, I just want to point out, you're retarding the evaporation of water. You're not retarding the cement hydration.
That's correct. I assume too much sometimes, but it was, yes.
On those slow-setting flatwork mixes, you mentioned using the evaporation retarder. Was one application enough, or were you applying a second coat either on it or driving and stuff like that?
Depending on the time of year, one is enough. One to help close it with the bull float, and then but if you get into the summer, you have windy conditions where the drying is a factor at all. We were reapplying it then after bull floating. And more than, I'd say 90% of the time, one application after bull floating was appropriate to keep it alive.
How are they doing that with those large square footage?
Hudson sprayers on poles. Yeah, and as they go, you're right. It's the fact of the matter is, on a larger deck, it's almost impossible to give it a second application after you leave that site, except around the edges. So, yes.
Sure, that's class F, class C.
They were C's in the back.
Let me suggest that you ran C.
It's the modified 7-day wet, 28-day dry.
What was the required slump life of this concrete, and when were any adjustments allowed to job site?
Yeah, we didn't. There were adjustments allowed on the job site. We didn't use those adjustments too much, and if we did, it was additional super. We came from Burnsville to downtown, so probably 45 to 50 minutes to get there, and then another, mostly pump placement, so another half hour on site. Slump life was really good.
Question regarding flatwork. Did you guys use mixes with 25% fly ash or higher than flatwork on this?
Everything, yes. They had 30% ash, 10% slag.
And no issues with finishability as far as stickiness on the trout?
They were a little sticky, but yeah, we got a lot of blowback for a while when we first started to use these. Like, they were sticky and they didn't finish well, but everybody's gotten used to them and they finish okay.
And then did you guys do a 24-hour break on the cylinders to gauge your high volume fly ash?
We did on a few of the pan and joist slabs, yeah, and it met 3,024.
Remarkable, actually, yeah. Any other questions? Way in the back.
Do you have any issues with drying time on the floor and applying moisture-sensitive working conditions?
No, that is, in fact, that's another benefit of these. When you have that low total cementitious, and then you keep your water-cement ratios moderate, the amount of water in these concretes is relatively low. And we have not seen any problems with drying, reaching that magic transmission level of, what is it, 3?
It's usually 4
4?
or 80%.
Right. That is another benefit of these mixes. They dry out. Any other questions?
What type of floor coverings? You have carpet or VCDs?
Yeah, I'm trying to think, Linda, did we have any floor coverings that were not breathable?
The gym, right? That would be.
The athletic floorings are
A rubber?
product.
Right. So there are rubber matting products on the running track and in the gym. Other than that, it was carpet.
A few with wood floors.
And some wood floors too, of course. But they all breathe.
Do any washer mitigation system?
We're actually flushing out the building now as it's being completed with high volumes of air, exhaust, and flushing the building for sustainability reasons prior to occupancy.
Yes, other than the typical flushing and dust mitigation and so on, we're not aware of any problems of that nature.
But I know the guys went in and tested, and it met all of their levels to at least. Yep.
All right, thank you.